Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's webinar, Speed Up Silicon Carbide Adoption with Useful Power Module Reference Designs, brought to you by Tech Online, Wolfspeed, and Arrow, and broadcast by AspenCore. I'm Todd Neff, and I'll be your moderator today. We have just a few announcements before we begin. The slides will advance automatically throughout the event. You may also download a copy of the slides by clicking on the green folder icon located at the bottom of your screen. You can participate in the Q&A session by asking questions at any time during this webinar. Just type your questions into the Q&A text area located to the right of the presentation window, and then click the Submit button. At this time, we recommend that you disable your pop-up blockers. At the end of the webinar, we'll ask you to complete our feedback form. Your feedback will provide us with valuable information on how we can improve future events. You can also launch the survey at any time by clicking on the red survey button at the bottom of the console. If you're experiencing any technical problems, please type your issue into the Q&A text area and we'll be glad to offer one-on-one assistance. Now on to the presentation, Speed Up Silicon Carbide Adoption with Useful Power Module Reference Designs. Discussing today's topic is Jonathan Hayes. Jonathan is an applications engineer for modules at Wolfspeed. He's been with Wolfspeed as an applications engineer in the Power Modules unit for the past 6 years. His areas of focus include the design, validation, and application of Wolfspeed SiC power modules at the low to medium voltage level, with a specific focus on customer application support and education. And so with that, it's a great pleasure to hand things over to Jonathan to begin. Jonathan, take it away.
Thank you, Todd, and welcome, everyone. Thank you for taking some time out of your day to join us for this talk. I'll go ahead and just get right into it. So really the purpose of this presentation today is to provide an overview of the tools and collateral that we provide as a company to help you evaluate our power modules and our products and design them in with as little effort as needed. So really this is in our DNA as a company. So we want to inspire design engineers to create powerful yet simple designs, enable them to build more efficient systems, but also with minimum system level trade-offs. So as we look to help those of you transitioning from silicon to silicon carbide, or even compared to other silicon carbide module manufacturers, really, how can you get the best and most benefit from the products that we offer, and help you reduce your overall system size, complexity, cost, and et cetera. So really, again, we strive as a company to provide the tools necessary for you and make your job easier. So providing that application-specific advice to help you choose the right product for your application. So some of the webinars we've done in the past have focused on applications, but really today we're going to be focusing on the evaluation tools and reference designs that we offer as a company to help you. So this will be our agenda, and I'll try not to make it so much a sales pitch, but just, again, we wanted to provide you with the information of what we do offer to help make your job easier. So our ultimate goal is to sell power modules and get those design-ins into your system. And so, again, we try to make that as easy as possible for you, which is both beneficial to yourself and to us as a company. So really our agenda, going through the reference designs, starting with board level all the way up to fully integrated systems. So we do offer gate driver boards, and we'll cover what those entail. But really they're companion evaluation tools to help you get up and running very quickly. And then next we'll kind of touch on the dynamic evaluation kits that we offer for each module platform. And so this is really, the dynamic evaluation kits are to help reduce the design resource investment. So you're taking our engineering skills and knowledge and development and purchasing a kit that will enable you to evaluate our modules quickly together with the companion gate driver tools. And then finally building up to complete system reference designs. So like the dual inverter 600 kilowatt kit that you see here. So this really enables design engineers to create rugged and reliable systems, and then we can demonstrate best-in-class power density, performance, and efficiency, and also provide key lessons learned as you're trying to implement our silicon carbide devices. So first, our gate driver boards. So we offer companion gate driver boards for most of or all of our power module platforms to some extent. So here we'll look at, as an example, our XM3 companion gate driver board. This has been available for a few years, ever since we've introduced the XM3 power module, but it's a simple direct plug-in gate driver board. You can operate it up to a 1,000-volt DC bus, and depending on the variant of the XM3 power module, the 400, the 425, or the 450, it can provide a switching frequency up to 80 kilohertz with the 2-watt power supplies on board. But really the takeaway here, as you can see the block diagram of the gate driver, is that we provide all of the functionality required to not only run double pulse tests or clamped inductive load tests, but also do full power testing, continuous testing with these gate drivers. So we provide the proper protections, including DSAT, and in this XM3 driver, utilizing an ADI all-in-one gate driver chip, has the Miller clamp connection, and then user configurable turn on and turn off gate resistors. Then another key aspect is on the input signals. We provide differential signaling in, and I'll touch on our differential transceiver companion board in a minute, but really this provides robust signals that increase the noise immunity. So really we've done the full work on this driver architecture to enable you to not have any issues from the gate driver side. So as you're going through your evaluation, you don't have to worry about issues from noise or the gate driver performance, the output buffer stage, some of the things that you can run into as you're developing or evaluating a module. So we've done all that work for you. So again, it just makes your job easier. So what do you get with this companion gate driver board? So again, you can purchase this gate driver, so it's available on our website. So if you're just looking to test real quickly, then go on there and purchase a board. But also what you get together for free and just available from our website to download is the complete reference design files. So as you see in the right-hand table, all the information that you get with this gate driver design. So the board specs to be able to, along with the Gerber file, so you can actually order the boards yourself, a complete bill of materials, again, the layout artwork and the schematics. So not only is it a physical hardware tool for you to use, it's also, again, a reference design, so you can take and learn and see what we've done as a power module company, which has optimized a gate driver for our product, and then implement that into your own design and your own board. So that covers the XM3 driver. And just wanted to touch on quickly, I just used the XM3 as an example, but again, we offer these companion gate driver boards for all of our power module platforms. So the main ones would be the 62 millimeter modules. So we have a Gen 2 and a Gen 3 gate driver board. And then for our new Wolfpack platform, both the FM3 and GM3 have compatible gate driver boards. So one that we've developed in-house, and then also we have 3 variants that were developed through our partner, through 3 different partners. So not only are you taking what we've done, but if you like a particular chipset or a particular company and partner, then we have that available as well that you could, and it's very similar. You can purchase the boards, or you can download the design files to see what each of those companies have done to optimize the gate driver around their particular chipset. Then lastly, a driver board for our high performance HM, which is the high performance 62 millimeter module. So again, please check out our website for this list, and just know that it is available to purchase and to download the reference design files. So another tool that we offer that we found to be quite valuable is our differential transceiver daughter board. So like I mentioned, covering the XM3 gate driver, the input signals are mostly differential. So the critical signals like the PWM and the fault feedback are in the RTD, the temperature sensor feedback signals are differential. So we found that this is a pretty simple design choice to make to really increase your noise immunity. But we also realized that most people might not be set up to provide differential signaling that easily. So what we've created here is a differential transceiver board. So what it does is takes single-ended low voltage signals, either 3.3 volts from a microcontroller or 5 volt signals, logic level signals, single-ended, and then translates them via a transceiver to the differential signals. So we have a differential driver and transceiver chip. So this is available for purchase as well, and would highly recommend if you don't have differential signaling capabilities already, to go ahead and grab this tool. It's fairly cheap and a very cheap investment to save you quite a bit of headache in the future. As you, again, as you're evaluating a power module in particular, we want to take away as many potential problems as possible. And signaling and the PWM signal and gate driver and can be, a headache that you would have to overcome before you could truly evaluate the performance of the module. So we're just trying to remove that burden from you. So that concludes our board level reference designs. And so now I'll get into some of the dynamic evaluation kits. And as an example, here you can see our dynamic evaluation kit for the GMA, which is our half-bridge GM3 Wolfpack module platform. So again, I'll cover it in just a minute, but we offer these dynamic evaluation kits for most of our module platforms. So, but I'll just use this GM3 as an example. But really what this dynamic evaluation kit is for is exactly what the name suggests. So this would be for clamped inductive load or double pulse testing, to really so you can evaluate the module. And again, so what we've done is we've taken our engineering expertise and our silicon carbide measurement and testing expertise, and tried to provide this platform that you can purchase and buy. So then you can evaluate the modules in the same light that we, as a company, in a power module manufacturer, as evaluate our products. So included on the board is bulk capacitors, a high bandwidth shunt current viewing resistor to measure the low side current, the source current of the low side device. So depending on the configuration of the load inductor, you can measure normal switching, like the waveform shown here in the bottom right, or you can evaluate reverse recovery. And so what and also, so what we include is try to include decent measurement points, so you can measure drain to source voltages, gate voltages, things of that nature, and try to create really high fidelity, repeatable measurements. So again, you don't have to worry about how you're going to make the measurement, or what is this measurement the best that I can make. We've tried to do that built into these boards. So, and another thing that you can do. So, for instance, with this Wolfpack platform, I had mentioned previously all the partner gate drivers that we have. But you can see here that the gate drivers can actually plug directly into the board. So really this kit allows you to evaluate switching loss, timing, overshoot, the switching speed. So again, the full dynamic characterization of the power module across a bunch of different parameters or variables like bus voltage, current, even junction temperature, gate resistance, things of that nature. And then finally, again, with the gate driver evaluation, you can look at things, evaluate the different partner drivers, or look at gate driver practices like unipolar versus bipolar voltage rails, which is a big topic maybe coming from silicon or other silicon carbide manufacturers to our silicon carbide Wolfpack modules, or you can evaluate the need of a Miller clamp or how that affects the performance of the module as well. So again, here these are available for purchase from our website, and so what you would receive would be this fully assembled test board that you see on the screen here, and so the gate driver and the module would have to be purchased separate, but you can also download all of the design files. So if you weren't interested in necessarily purchasing a board, but just interested in the layout, how we make the measurements, or the bill of materials, that's all available as well for free from our website. So again, just to try to help you to speed up the evaluation and provide these resources, so you're not sitting there scratching your head or turning the wheel trying to create your own evaluation kit, which takes time and money and effort. We've tried to provide this for you to help speed up that process. So again, we try to provide a kit for every module platform that we have. So here's some. I demonstrated the GM3 Wolfpack, and we also have an FM3 variant for both the 6-pack and the half bridge modules. But here again, showing that combined with the companion gate driver boards that I covered, the dynamic evaluation kit and the module, the foundation is in place to quickly evaluate our module products. And so again, reduce design resource investment, enable fast characterization of our products. That's really the goal of these evaluation kits. And so putting it all together, I just wanted to demonstrate kind of how this would look together with our evaluation kits, the gate driver, the companion gate driver, and our differential transceiver. So here's kind of what you can purchase, everything on the right, and then if you have an existing legacy microcontroller or function generator or something that you like to use for your double pulse test setup, you can interface with that differential transceiver pretty easily. And the general goal would be to keep those signals as short as possible on the single-ended side. And then it's always necessary for safety, or if it's in an enclosure, or just based on where the scope is or the test bay, that the differential signaling might need to be a little bit longer. So really, but that's what the differential transceiver tool is for, to provide those differential signaling to help prevent any issues from noise coupling in. So this is really what the setup would look like. And again, if you purchased the three components and then as well as the module, you can get up and running and start evaluating our products fairly quickly. Once they arrive, and out of the box, they should be ready to go. So now on to the system reference designs. So we've covered the board level and the dynamic evaluation kits, and then now we'll transition to these more system level designs, which encompass all the lessons learned from the evaluations that could be done with the previous two categories. So the first one I'll cover, so these will be our power module reference designs. So this first one is the 25 kilowatt bidirectional active front end reference design. So this is based around the 21 milliohm 6-pack FM3 power module. And you can see the full system in the bottom. What we've tried to do is make it realistic to where you have all the functionality required for a grid-tied system. And then the top photo would be the actual power stage of the FM3. And here in this reference design, we included the use of our universal Wolfpack gate driver. But again, it would be possible to evaluate our partner gate drivers with this board, as it's a kind of a plug-and-play style gate driver connection. So for this reference design, what you get is it's not available for sale, so it's not hardware that's available, but you can download all the relevant design files. So this includes the assembly BOM. We do offer there is a controller with so you can download all the files for the controller and the filter and the power stage, which would include Gerber files, bill of materials, the layouts, schematics, things of that nature, and then a rendering. So what this really demonstrates is a building block for other systems. So we'll go through the block diagram real quick. And kind of see what we have built into that system. So we have everything necessary for safe operation, fuses, contactors, a pre-charge circuit, which is a diode bridge and resistors. So it's more geared towards a higher power level pre-charge. So you could take this as a building block and scale up the power if needed. But we have just an off-the-shelf EMI filter, and then a filter board with X and Y capacitors, the proper voltage and current sensing, custom inductors for the boost inductors, and then of course the power stage would include the 21 milliohm 6-pack FM3 Wolfpack module, and then 3 of our universal gate drivers. And so one thing to touch on some of this application, and with silicon carbide, it's possible to simply use a 2-level converter. So with IGBTs, if you look at the silicon IGBT solution, while the 2-level topology is simple and inexpensive, you're really limited on the switching frequency. And to kind of overcome some of the switching frequency limitation or the potential efficiency limitations, can look at going to a multi-level converter. But this, of course, requires more components, which would increase the system cost and complexity. So with our 1200 volt Wolfpack modules, it simply enables a high efficient, 2-level simple active front end converter. So we can still achieve relatively high efficiency, and with the Wolfpack module, it's still high power density and relatively low cost. Even with the Wolfpack, up to 100 kilohertz switching frequency. So really pushing the power density and shrinking the size of the magnetics, and while still maintaining a fairly high efficiency. And so where can this building block be implemented? So really a hot topic lately has been DC fast chargers. So where you could use this building block as the front end for what we have here is 2 different topology architectures. The first would be to have the active front end, and then an isolated DC-DC stage where you would have, or we see the need where there would be an isolated DC bus. So from here, you could have energy storage, and then you would need a DC-DC stage to regulate the output to charge the battery. And another option would be just the 2-stage approach, where you have the active front end at the front, and then something like an LLC converter to regulate that DC output to charge the battery. And then with the Wolfpack, to scale up the power, it's fairly simple and straightforward to go from, say, the 6-pack FM3 to the half-bridge FM3 modules, or even to utilizing the GM3 modules. So one of the key aspects of the Wolfpack platform is that it's easily scalable, and we provide many options to help you scale with power, or with switching frequency, or with, if you need a lower junction temperature to increase lifetime. So there's quite a bit of options from the Wolfpack power module platform to achieve your overall goal. So the next reference design is the 300 kilowatt 3-phase inverter. So this has been around for a few years, ever since we've released the XM3 module, but it's been quite popular as it's a very power dense solution for 300 kilowatts. So this is actually available for purchase as well. And what you get is what you see here, is the fully assembled, highly integrated inverter hardware. And so again, not just the hardware, but you can download the design files for free. This includes the application note, all the design files, including Gerber files, bill of materials, CAD renderings, things of that nature. So again, you can get those files to learn what we've done and to see how we've implemented this as a system. And so this is simply a three-phase inverter. But what we have here is some DC bus capacitors. It's not really targeted for any particular application, but assuming if it was something like for traction, but we do have some DC bus capacitors to help with and those are sized appropriately for the ripple current rating and energy storage for the 300 or 360 amp output current that is capable for this kit. So this entire kit is based around the XM3 module, of course, and really we have three variants. So any of the three variants can fit into this particular kit. It has the DC bus voltage sensing and output current sensing built in. We also provide a controller as well. And I'll touch on we do provide firmware for the controller, and I'll touch on that here in the next slide. But this interfaces with our companion gate driver board. So we use that XM3 driver board that I touched on at the beginning of the presentation. So we use that in this kit. So again, it is an evaluation tool, but it can be used, for full power testing and in system as we demonstrate with this reference design. So the firmware that we do offer, it really is just simple open loop sine PWM. So we also offer a CAN communication GUI. So out of the box, this comes set up and ready to go for just this simple sine PWM output. So you can, if you had like a half bridge converter, which is what we do some of our testing on, kind of recirculating load tests, then out of the box you can automatically run get voltage and current waveforms that as you see on the screen here. And so the CAN communication GUI, which is all detailed in the application note, how to download and then install it and get it up and running. But you can control the switching frequency, the modulation factor, and dead time, the fundamental frequency of the output, and also control the different power and logic disables, enables, and reset for the gate driver. So again, out of the box, you can essentially get up and running fairly quickly as it comes preloaded with the firmware that had been tested. Each kit's tested, so you could start generating your own voltage and current waveforms from the get-go, or even spin a motor to some extent with this basic control. But what the firmware does is it really provides that foundation of we initialize all the proper PWM signals, the GPIOs, the ADC converters. Everything's initialized and then provided as a shell foundation for you to go in and implement your own control. So we are by no means control experts, but we still try to provide that foundation to make it easier for you to go and implement your own control in the controller. So one of the key learnings from this reference design, not only the entire stack up of the thermal, the cold plate and the module, the gate driver, the differential signaling, but the bus bar guidance is a huge takeaway that you could get. So as you see in the schematic in the top right with the DC, looking at the overall commutation loop, we have a bunch of contributors to the overall parasitic loop inductance. So from the DC link capacitors that have an ESL, there's the inductance of the bus bar itself, and then of course the inductance of the power module. So what we see, this might be a little drastic, but with the IGBT inverter, really high inductance of the power module, and depending on the busing and the capacitor stack up, we can see a really high overall loop inductance. But with our silicon carbide inverter and how the XM3 power tabs are laid out, you can see we can achieve a really fairly low overall loop inductance of this loop that you see with the DC link capacitors, bus bar, and module. So you can see from this cutaway view, the capacitors that we've found and we've implemented are very low inductance, and we use three in parallel, so that also helps. But the laminated DC bus structure is right on top of each other, so we have a lot of flux cancellation in the loop, and then the power terminals of the XM3 make it very easy to bus to, and the low inductance of the XM3 itself. So you can see there's, just based on the physical geometry, it's a very small, tight loop. So it helps us achieve a very low overall commutation loop inductance of roughly 14 nanohenries, so which includes the capacitors, busing, and module. Again, the busing files are available, so you can look at the CAD files. You can even purchase the busing yourself from our partner. The busing was developed with Rogers Corporation, so it is available. But again, this is to teach you how to do it, how we would do it, how we've implemented it, so then you can take it and run with the design for your particular application. So another XM3 reference design, one that we've released in the last couple of years, steps up the power to 600 kilowatts. So it's essentially a dual inverter, or as you can imagine, two of the 300 kilowatt inverter kits. So what's included here, again, this is available for purchase. So if you are interested in evaluating the modules, that if you had an application at this power level, or were interested in this either a dual inverter concept, or you can parallel the outputs to make it a single 600 kilowatt inverter. But this is available for purchase, and what you get is the fully assembled inverter hardware. And again, we also have the reference designs available. So the entire stack up, CAD models, Gerber files, schematics, bill of materials, everything once again is available for download. And similar to the 300 kilowatt inverter kit, you can request the firmware and the CAN communication GUI separately, and we can provide that to you. But looking at this kit, again, it is a dual inverter, so it is basically two separate three-phase inverters. But what we've tried to do is make it the stack up and the form factor of these inverters as symmetrical as possible. So you can, if you parallel the outputs, which would parallel two XM3 modules, you can go from two 300 kilowatt inverters up to the 600 kilowatt nameplate of the dual inverter. So here again, the stack up includes a cold plate, the XM3 power modules, the gate drivers, a controller board once again, and DC bus capacitors and the proper voltage and current sensing on the output phases. So all in a very compact, very high power dense design. And so one of the key learnings from this reference design would be the dual power core. So similarly to the 300 kilowatt kit with the cold plate, XM3 power modules, and then our companion gate driver board stack up, what we've done in this dual inverter is actually utilize a dual-sided cold plate, so modules can mount on both sides. And so this is offered from one of our partners, Weiland Microcool. And so what they've done is create a very small form factor for our cold plate for our XM3 power modules, and with their micro deformation technology and stir welding to each side, we're able to achieve very balanced parallel cooling from this extruded cold plate. So so modules can mount on both sides, and that's how we achieve that really compact power dense design that also makes the busing very symmetrical, which I'll get into in the next slide from the capacitor. But here you can see, what this power core kind of looks like with the cold plate and the power modules, and then we demonstrate how to utilize the companion driver and create this entire stack up, which is the foundation of the entire dual inverter kit. And so with that dual power core and what this kind of double-sided cold plate helps us achieve is actually when paralleling modules, you want to keep the commutation loop for each module very symmetrical and the same. And so with this kind of sandwich approach, what we did is we engaged with Electronic Concepts to develop this custom capacitor. So this is a custom DC link capacitor with integrated busing. So as you can see on the right here, moving from the 300 kilowatt kits with 300 microfarad capacitors, if we were to double that to 600 microfarad capacitors, the form factor is not quite there, and how you would have to mount the capacitors and bring the busing out to then try to get a symmetrical connection to both sides of the power modules would be difficult. Otherwise, you would have to go put all 6 XM3 power modules laterally, which would increase not really take advantage of the power density that could be achieved. So we went with an integrated approach with the integrated busing that comes out and connects directly into that dual power core of the modules. So we do take a slight hit in the inductance of this capacitor and DC link busing, but that's a trade-off that is easy to make in terms of it doesn't really affect the overall performance of the stack up, but it allows us to achieve a really high power dense design, as you see. So a pretty easy trade-off to make, but really enabled by the double-sided cold plate and this custom capacitor. So this custom capacitor is available. You can see the design files for it from Electronic Concepts, and understand what we did with them to create this custom integrated busing solution. So another key learning from this 600 kilowatt kit would be the current sensing. So for the 300 kilowatt kit, to compare to. We utilize limb sensors. So these are commercial off the shelf. They're very nice. They're very easy to use, easy to implement. As you see the structure with the output phase busing going through them, and they're closed loop sensors, so very high accuracy and our current feedback, so very immune to noise, and a very nice solution overall. So a pretty simple choice for the 300 kilowatt kit. But moving to the 600 kilowatt kit, we're again aiming more towards power density, which, as you can see from the previous couple of slides with the double-sided cold plate and the custom capacitor, to achieve that power density, we kind of have to go to a more custom, complex solution. So, but what we've done is implemented the Melexis current sensor, so it's a Hall effect sensor that requires a ferromagnetic shield to concentrate that magnetic field and measure the current that way. And so this again is a very and it enables a very compact solution. It is more custom, again similar to the capacitor for the 600 kilowatt kit. But this one, as you can see, enables us to achieve a really power dense compact solution. And so with the 600 kilowatt kit, of course, we would need 6 sensors, one for each output phase. And so it's even though it requires an additional PCB, the shielding and a structure to implement, it's still fairly simple to implement to achieve that compactness. So as you're looking for, and it is automotive qualified, so if this is geared more towards a traction solution, you have that benefit. But again, the key takeaways for the current sensing from each kit, if you're looking for solutions on how to do that, we provide a couple of different solutions that both have their own benefits that you could take away. So real quick, the what's included in the firmware and the CAN communication GUI. So very similar to the 300 kilowatt kit, it's just doubled for each inverter. So you can see the controller hardware here. Again, it's based on the TI C2000 class controller. And what we provide is, again, just simple open loop sine PWM. So depending on how you have the output phases configured, it can be 2 inverters, or it can be a single inverter to achieve the high current 600 kilowatts. So again, out of the box, it comes with this basic firmware for you to then take and kind of customize to your specific application. But the foundation is there to start testing it immediately. And so from these XN3 reference designs, where we see these kind of fitting in, we've done a previous webinar on an active front-end design. So this particular design is air-cooled, but to make the comparison, but really, again, with silicon carbide and our 1200 volt modules, a simple 2-level active front-end topology is achievable. And so even what you see here, a comparison to a silicon IGBT incrementation, you can increase the switching frequency while still decreasing, increasing the overall efficiency of the system. And so by increasing that switching frequency, we're able to decrease the filter, the inductor, and the DC link capacitor sizes, while also having lower loss. And so really what's demonstrated here is, again, going back to the beginning, you know, how you can save costs in your system, reduce, make it more efficient, while still reducing the size and costs of the passives like the inductor or the capacitors or the heat sink or thermal management system. So these kits, the 300 kilowatt and 600 kilowatt, they can be implemented you know, as an inverter or as an active front end. So again, back to the same kind of charger topology that was previously touched on, the two-stage, utilizing the inverter kit as an active front end to then have something like an LLC stage on the output to provide a really high power DC fast charger. Another application would be a double conversion UPS system, which was also covered in a previous webinar. That's available, but really the XN3 here could be used for the active front end on the front end, and then also the inverter, the grid tied inverter on the output. So with our half bridge modules, also being able to use for the DC-DC converters to implement the battery, but really these kits can be used as building blocks within these applications. So you can buy them to test and evaluate, or use the reference designs and then fit it into the particular application that of your interest. So that's really all I have from the reference design perspective, but I just wanted to close before questions with, again, pointing you to our website. Most of the information covered here can be found on our website. So if you go to Tools and Support under Power Products, you can see there's a link for the gate driver boards, the evaluation kits, the reference designs, and we have a huge collection of application notes and articles and videos available to kind of cover all of this information. So our website really is a great resource for this. So please visit the website and reach out on our new forum. We have a technical support forum now for you to ask questions that engineers such as myself and my colleagues can answer directly to help you. So I'll pass it back over to Todd for questions. Thank you.
Thank you, Jonathan. And yes, on to the question and answer portion of our event. As a reminder, to participate in the Q&A, just type your question into the text box located to the right of the presentation window, or click the Q&A icon on the bottom of your screen, and then click the Submit button. So we have a couple that have come in. Let's start with this one. Can the outputs of the CRD 600DA12E XM3 be paralleled directly, or does each inverter need inductors on the output before paralleling?
Yeah, so they can be paralleled directly. So the outputs are kept separate. We wanted to provide that flexibility from your end to decide how to use those. But really, when you look at paralleling modules, you want the DC busing to be symmetrical and the AC busing. And so if you look back at at kind of the form factor and the structure of that output busing, and I believe we've covered it in a previous webinar as well, but how to parallel those outputs. But yes, if you simply connect those, if you create something like a bus bar to connect those in parallel, the top and bottom terminals, and you keep that fairly symmetrical for each module, it's very simple and straightforward to parallel and run those.
Thank you. Will you be releasing more Wolfpack reference designs?
In short, yes. So the Wolfpack, the reference design we have is the 25 kilowatt active front end, and that's more of a paper design demonstration. And in the future, we're targeting trying to provide more hardware and reference designs similar to the XM3 inverter kits, where if we could provide inverters with the Wolfpack so you can actually get hardware in your hands and start testing, very similar to those XM3 inverter kits. So that's in the works, and hopefully will be available soon. But yes, we are targeting more Wolfpack reference designs.
Next question. Do you have a reference design for the isolated DC-DC converter for EV fast charging?
Yes. I would assume that the question is referring to the Wolfpack. That is another reference design that's in the works. And we have some preliminary information over that design. What we've targeted is the 3-stage approach, where you can implement that isolated energy storage bus. So what it is an active front end, a series resonant converter, which is just a 1-to-1 isolated converter, soft switching, so very, very high efficiency just to provide that isolated bus, and then an interleaved buck or DC-DC converter on the output to provide that regulation. So we have some preliminary information available, so you can reach out to your sales team or the FAEs that you engage with, and we can provide some of that preliminary information, and we'll be releasing that reference design within the next year or so.
Now the question, what are the variants of the XM3 can be used in these inverter reference designs?
Yeah, so we have all three flat base plate modules available for purchase. So they're each rated at 200, 250, and 300 kilowatts. So each of the flat base plate variants can be purchased right now. And so another thing that we offer with that dual inverter kit and with the 300 kilowatt kit is the same tubs are compatible for the pin-fin variants of the XM3, which it's not available commercially, but there are the option to implement a pin-fin version to have that direct cooled. So each kit is directly compatible with those variants as well to help increase the power levels.
Are gate drivers available now through your distribution sales channels?
They are, yes. So you can, again, I would recommend going to our website, and under that Purchase Now button, it'll bring up a list of our distributor stock and where you can purchase those drivers.
Can you supply firmware? Oh, sorry. Can I use your gate drivers for mass production?
So these are really designed to be evaluation tools and a guide of how to develop your own driver. So while functionally and they can be used for mass production, we will not provide that volume. So it would still be your responsibility to kind of take those design files and then have the drivers made yourself, and then of course validated within your system for use. So they're really geared towards, you can purchase them now and you can use them for evaluation and see how to best do your gate driver. But we do not produce at high volume, so that would be your responsibility. Great.
Jonathan Hayes, thank you so much for the presentation and for answering those questions. we are short on time, so for more information related to today's webinar, please visit any of the resource links available in the green folder at the bottom of your screen. Within 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Thank you for attending today's webinar, Speed Up Silicon Carbide Adoption with Useful Power Module Reference Designs, brought to you by Tech Online, Wolfspeed, and Arrow. This webinar is copyright 2022 by AspenCore. The presentation materials are owned by or copyrighted by Tech Online, Wolfspeed, and Arrow, and the individual speaker is solely responsible for his content and opinion. On behalf of our guests, Wolfspeed and Arrow, I'm Todd Neff. Thanks for your time, and have a great day.